All right. Hello and welcome to day 6 of the workshops for the E3OD 2023 Meta Web3 Builder Competition. My name is Kyle and I will be your host today. E3OD 2023 is a Web3 summit dedicated to Ethereum and designed to gather developers and builders from Riyadh, Saudi Arabia, and other Middle East regions. E3OD aims to provide insights from industry experts and engage in discussions around the future of blockchain. A big thank you to the Community Organizing Committee, Therawatt Technology, Studio 1727, Chain IDE, Coffee with Crypto, and Mask Network. The event schedule includes the online boot camp and competition from September 18th to October 10th, the in-person reception and conference on October 10th and 11th, and the online closing mixer on October 12th. So thank you all for joining us for the final day of these workshops for the E3OD Meta Web3 Builder Competition. A last reminder that the registration for the competition is still open and there's a total prize pool of $30,000. The competition submission deadline is October 10th. For the latest information and updates about E3OD and the competition, please follow 0xE3OD on Twitter, join the official E3OD Telegram, and visit e3od.com. Now, before we get started, let's take a moment to thank the event sponsors for the competition: Web3 Port, Moon Capital, Adaverse, and Chili's. With that said, we can jump into day 6. We have 2 wonderful guests today giving workshops. We have Cara, a security expert at Zan, and Tamaghna Basu, the founder and CEO of DeTaSECURE. So, if you have any questions during today's sessions, please leave them in the live chat. The team will gather them and the answers will be posted in the Telegram at a later time. So we're going to turn it over to Cara for their workshop, How to Write Secure and Gas-Efficient Smart Contracts Using Solidity.
Hello everyone, my name is Cara and I'm from Zan. Today I will talk about how to write secure and gas-efficient smart contracts. Our discussion will be structured in 3 sections. In the first part, we will kick off with a real-life incident where a smart contract vulnerability led to significant losses. In the second part, we will walk through a set of examples to highlight some common security issues and the best practices to mitigate them. Additionally, I'm gonna share some gas optimization strategies. Even the best developers can overlook things, so in the last part, we will explore tools that can help us to write secure and gas-efficient contracts. I will provide a live demonstration of how to use them during development. First, let's take a look at this real attack case. The famous wallet, Pirate multisig wallet, was attacked due to lack of access control of critical function. It suffered a loss of $30 million. Here we will explain the attack trace. First, attacker called a non-exist function in contract wallet with the core data. It finally called fallback in the contract wallet. In function fallback, attacker can delegate call any public or external functions in contract wallet library, including the function init wallet. In function init wallet, attacker changed the owners of the contract wallet, which has no permission check. Finally, attacker called the function execute, which only owner can call to send all funds to an account controlled by the attacker. Such security incidents, unfortunately, are not isolated events in the Web3 ecosystem. They underline the challenges and the importance of smart contract security. As we move forward, I will break down an example contract based on the ERC20 standard. We will explore the best practices to employ and the pitfalls to avoid. Here we can see the contract. In the contract, users can transfer ETH to mint token by calling function mint, or burn tokens to get back ETH by calling function burn, Also, these tokens can be transferred between different addresses by calling function transfer or transfer from. These are the main functions of the contract. Next, let's look for vulnerabilities in the contract as well as gas optimization points. The first vulnerability is about unchecked return value of function call. In 984, when the function burn is called, the contract will burn the sender's tokens and transfer the corresponding ETH back to the receiver, specified by the sender by calling the low-level function call. However, we can see that the return value of the call is not checked, which means that if the call operation fails, the sender's tokens will still be burned, causing asset losses to the sender. We recommend to always check the return value to ensure the success of the call for this type of low-level call. The second vulnerability is also here. When a call is made here to a sender who is a contract, the fallback function of the sender is triggered, and the sender can re-enter the burn function, since the balance of the sender has not been updated at this time. These pre-checks will be bypassed, so the sender can repeat the process of retrieving ETH and obtaining profits that do not belong to it. We recommend adopting the checks effects interactions pattern to perform critical operations. For example, in this function, the sender's balance should be deducted first, and then making the external call. Or you can add a re-entry lock to critical functions to avoid re-entry vulnerabilities. The third vulnerability is in function set owner. Function set owner is used to modify the owner of the contract. Due to the lack of access control, anyone can call this function to modify the owner to another address. This will result in the entire contract being taken over by the attacker's address, and the attacker can call the function withdraw to take away all ETH in the contract. We recommend ending access control for functions that modify critical state variables. There is another risk here. This function doesn't check if the input parameter account is zero address. If caller sets the owner to zero address accidentally, which would cause functions that only the owner can call, not work. We also suggest emitting an event when modify critical variables like owner, which can be monitored by off-chain tools. In this contract, in addition to these vulnerabilities, there are also some points where gas optimization can be performed. For example, one optimization point is in 964, where the require function is called. The second parameter of the require function represents the error message. As the string length of the error message exceeds 34 bytes, it will consume more gas. We recommend keeping the error message of the require or revert within 32 bytes to save gas, or using customer error directory whose error message will compile to only 4 bytes. For example, this approach is used in 926, like this. Well, these are all the points I want to say in this contract. As we mentioned earlier, using a re-entry guard is necessary sometimes, but there are also some tips you should know. First, we don't suggest using re-entry locks to modify functions with internal visibility. Moreover, you must not call a function with a re-entry lock from another function with a re-entry lock, and this can cause the function not to work. For example, in the following contract, the function band calls the function called. When calling the function band, the non-reentrant modifier is executed. It will set the state variable to status to entered. When the statement call the function called is executed, the called function also executes the non-reentrant modifier. However, because the status is entered, the check on 59 will fail. As a consequence, the entire transaction will fail. In addition to the vulnerabilities and the optimization points mentioned in these two examples, I will briefly introduce some other vulnerabilities and optimization points. The first point, do not use checks origin for authorization. This can potentially lead to phishing attacks and bypassing permission checks. Let's consider this picture. In this picture, the function changeOwner is used to change the owner of the contract. On line 9, this function verifies if the TX origin is the owner, ensuring that only the origin of the transaction, who is also the owner, can actually change the owner. Now, there is an attacker who can induce the owner of this contract to call a contract deployed by the attacker and then invoke the changeOwner function within the attacker's contract. At this point, origin of the transaction will be the owner of the contract, where the changeOwner function resides, so the check will pass, allowing the attacker to change the owner to their addresses. To resolve the issue, the solution is to modify the check on line 9 to verify if the sender is the owner instead. This change can effectively avoid phishing attacks. The second point, we should be aware of precision loss when performing division operations, because in solidity language, when division does not result in an exact quotient, it runs down. This may cause access losses to the project party or users, especially in lending and exchange kind projects. For example, the function by quote in this picture is used to calculate the amount of tokens required for a token exchange. Here, the user inputs the desired quantity of token B to be purchased into the by quote function. After performing the necessary calculations, the function returns the corresponding quantity of token A required for the purchase. In this project, a transaction initiator is required to pay a 0.3% fee for each exchange. It can be observed that in operation on line 6, in certain cases, due to rounding down, the calculated value may be 0 or insufficient to cover the transaction fee. This means that the user can obtain the specified quantity of token B by offering a lower than expected quantity of token A, resulting in a loss for the project. One possible solution is to add 1 to the calculated value after the computation, which helps to prevent asset losses caused by precision loss in calculations. What's more, when the statement involves multiplication and division operations like the line 2 shows in the left picture, we recommend to multiply first and then dividing, which can reduce precision loss like the right picture shows. The third point, it is recommended to verify if the return value of the precompiled contract ETH is a 0 address when performing signature verification. This is because ETH returns a 0 address when processing invalid signature instead of reverting the entire transaction. Failing to check the return value of ETH can pose a risk of bypassing signature verification in certain business scenarios. Therefore, it is recommended to use the signature verification library contract provided by OpenZeppelin directly for enhanced security. As we can see, when the return value of the ETH is a 0 address, line 141 will throw an invalid signature error, and eventually the error will be handled in the throw error function, resulting in the direct rollback of the entire transaction. The fourth point, we recommend to use the safe transfer from, and the safe approve functions in safe ERC20 contract of OpenZeppelin to call the transfer from, and approve functions in the ERC20 contract. Because different ERC20 contracts, although adhering to the ERC20 standard, may implement functions differently. For example, they may handle unexpected situations differently. Some contracts may revert the transaction directly when encountering unexpected conditions within a function, while others may return false. To ensure compatibility with different implementations and to handle contract exceptions comprehensively, it is recommended to follow the approach shown in the second picture for the corresponding operations, such as using safe transfer from to transfer tokens instead of using transfer from directly. The fifth point, we should pass in core parameters when transfer ETH using core. Even if we only intend to transfer ETH using core, we still need to pass arguments to this core. Otherwise, as shown in the picture, after the execution of NAND2, ETH is not actually transferred to the receiver address, yet the transaction does not throw an error. This can mislead users into thinking that the ETH transfer was successful. We refer to this as an invalid ETH transfer. The correct implementation, as shown in the second picture, is to pass an empty string if there is no need to invoke a function in the receiver address while transferring ETH. Additionally, it is important to verify the return value of the core to ensure the successful transfer of ETH. The sixth point. When approving a spender to use our tokens, it is recommended to first approve an allowance of 0 to the spender and then approve the desired amount. This implementation is taken for compatibility reasons, as different token contracts may have different implementations of the approve function. For instance, in the approve function of the USDT contract mentioned, we can see on line 205 that the sender is required to approve an allowance of 0 to the spender before approve a non-zero amount. So it's better to first call the approve function to set the allowance for spender to 0, then call the approve function again to set the allowance for spender to the desired value. We have discussed 6 security considerations, and now let's move on to a few gas optimization suggestions. The first point. Parameters should be declared as core data instead of memory in external or public functions. In Solidity, core data is a special data location in the Ethereum virtual machine, and reading data from the core data location is much cheaper compared to reading from memory. About 300 to 400 gas can be saved with optimization turned off, while 120 to 150 gas can be saved with optimization turned on. The second point, when declaring variables, we should pay attention to the order of the variables, because storage in blockchain is expensive. If we can make multiple variables be packed in one storage slot by adjusting the order of variables, a lot of gas can be saved. For example, in the picture on the left, we need 3 storage slots to store these 3 variables. Each slot is 32 bytes. Since the total supply variable is 32 bytes, it cannot be combined with the decimal or owner variable in the same slot. To optimize storage, we can place the total supply variable after the owner variable. This way, the 1 byte decimal and the 20 bytes owner can be packed into one slot. By doing this, the storage consumption for the 3 variables would only require 2 storage slots instead of 3. This optimization would save 1 slot in storage consumption. The third point, when a state variable is read multiple times in a function, it is recommended to use a local variable to cache the state variable, because reading from storage location is very expensive. In the picture on the left, in lines 5 to 7, there are 3 consecutive reads of the balance of a certain address from storage. This means that there are 3 snode operations here. If we first cache the balance of this address in memory, there would only be 1 S-node operation and 2 M-node operations. M-node is much cheaper than S-node, which can save some gas. The fourth point, if the state variable is only modified in the constructor, it is recommended to modify the variable with immutable to save gas, like variable owner in this picture. If the state variable is never modified in the contract, it is recommended to modify the variable with constant to save gas, like variable name in this picture. Variables marked with the constant and immutable modifiers do not occupy storage space for state variables. Instead, they are stored directly in the runtime code, making their storage cheaper compared to regular state variables. The fifth point, for constants, if the visibility is set to public, the compiler will automatically generate a getter function for it. which will consume more gas than private variable during deployment. As we can see, the name variable comes with a name function that allows external parties to retrieve the value of the name. When it comes to smart contract development, there are numerous security and optimization points to be considered. Therefore, relying solely on manual checks can sometimes lead to oversights. It is a good choice to use tools during the coding process. Now I'd like to demonstrate a static analysis tool I use every day. It is a fully automated, very easy to use, yet extremely powerful tool. It has over 150 rules and can effectively detect most common vulnerabilities and gas optimization points, including all of those we highlighted earlier. Okay, let me show you how to use this tool in VS Code. Install the plugin Zan in VS Code. Click here, search Zan plugin. Here is the one we want. Here you can find how to get the access token, how to use it. Because I have already installed the plugin, I will directly show you how to use it. If you install the plugin, there will be a button you can click. Click the button, create a task. Enter a name, for example, test1. Select contract file. We select the contract we mentioned earlier. Create. As we can see, the text is finished. We can click View to view the report. We also can view detail. As we can see in this contract, there are 1 vulnerability of high risk and 2 vulnerabilities of medium risk, and 21 points of informational level. The vulnerabilities we mentioned earlier are here. Reentrancy vulnerabilities, call return value, and unauthenticated storage access. There are also some optimization suggestions here. You can click anyone to see where is the risk and what does the risk mean. Besides of the static analysis tool I have just shown, there is an entire suite of automated security tools at Zan, including fast testing and formal verification tools. For projects that require an extra layer of security, Zan proudly offers expert review service. Here, seasoned professionals will manually check every single line of your contract, making sure it is absolutely secure. As we wrap up, I hope you feel better equipped to write smart contracts with confidence and vigilance. Thank you for joining this session. For any further questions or support, please do not hesitate to contact us. Stay secure and happy coding.
Okay, a big thank you to Cara. That was a great workshop on how to write secure and gas efficient smart contracts. So next we're going to Tamaghna for the workshop on blockchain security.
Hello. Hi, my name is Tamaghna Basu. I'm the founder and CEO of a company called DeTaSECURE. We're a cybersecurity company for both Web2 and Web3. And we also have built this platform called DeTaSECURE. It's a fully automated audit platform for both Web2 and Web3, which means that you can do a mobile application audit, web application security audit, smart contract audit, cloud security audit, everything together in one single platform. Cool. So thank you so much for this joining this event, and thank you for attending this seminar. We would love to walk you through a brief concept of various security aspect in the blockchain and smart contracts. So these are my contact details. I'm available in Telegram, Twitter, and then you can go to this link tree where you can find all the details about our company, about our product, and myself and my contact info, so that you can reach out to us, whenever you need any more help. And our contact details are there mentioned below here. Cool. So brief about me. As I said, I'm the founder and CEO of DeTaSECURE and the creator of GetSecure. This is my fourth company. And before I started my entrepreneurial journey 10 years back. And before that, I was working in large enterprises like PayPal, Walmart, PricewaterhouseCoopers, etc., etc. And I also am a passionate trainer. I love community. I love giving training and teaching, because through that process I learn a lot as well. When I'm actually conducting a workshop or teaching, it's more than me teaching you guys, or someone attendees. I learn from them, and the fact that I have to prepare for a workshop gives me a lot of aspects of learning new things. So that's why I work, and I work with a lot of universities as a mentor, as an advisor, to actually guide them in terms of designing curriculums, deliver, and all this. I also work as a advisor for various startups in Web2 and Web3 space, right? And one interesting thing I want to say, I am also a very big fan of hackathons. I myself have participated in more than, I don't know, like 40, 50 hackathons. I won like, 15, 20 awards already across Web2 and Web3, which gives us a lot of cash flow that helps us to run the company. And it also helps us to network, learn, and meet new people. It helps us to get new opportunities. Also, to as a founder, I'm looking a lot for hiring people, so I get a lot of good research, good talents whom I can reach out and hire. And why I'm saying this is very important, because hackathon is a very important aspect, and I always highly respect people who take their time out to participate in hackathons, to learn new things, and build something innovative. So this is very helpful. Quick. So why security? I had like 100 different things I could have done in my life. Why security, right? Because one is we see there's a huge need, especially in the Web3 space, right? So there is a surge of attacks. Things are going really massive. The growth is like year on year, like 300%, 200% through 300%, growth of, attacks are happening, exploits are happening, money is getting stolen. Billions of dollars of money is getting stolen, not even millions. So that is actually shows that how important is security, and how much negligence is there, how much we're deprioritizing this thing. So this is a high time, we should think about it, and that is the reason, I kind of delved into it, dedicated myself to this field, and say that, let's learn and let's help others, and also, let's also help others to learn security, right? So primarily three reasons, especially in the Web3 space, we see there is a limited knowledge of security. Second is there is less efficient tools available for developers, and third is, if you go for audit, it's very costly. So we as a company try to solve that in three ways. We are doing this kind of workshops. We also are building various developer tools. So if you scan the code and join our community, we offer a lot of free tools which you can use it to do audits and everything. And third is obviously, we do audit ourselves. So this is the course we have built, which is a kind of we will be covering today some part of it, but this is a very extensive, detailed course, which of 2 days course, where we actually teach you hands-on security from beginning to end, in terms of writing code, fixing code, deploying a security tools, and running, etc., etc. So as I said, you can reach out to us. We can help you to do that. Now let's talk about some of the case studies. Let's start with that, how various big hack happens, what was the reason for that, and how it could have been prevented. because that will give you a perspective that sometimes it's so silly. And you might say that you might feel like, why, it's such a stupid mistake which actually makes this kind of hack, right? So we'll be talking about two very popular hacks. One is called Temple DAO hack and one is called DAO hack. And these two happen for two different vulnerabilities, access control and reentrance. So we'll be covering that today. So lack of access control. What is access control? Access control means very simple. I'm controlling the access to certain resources, as simple as that, right? So this vulnerability occurs when something which is supposed to be controlled, or let's say the access should be minimized to a specific set of authorized people. However, we fail to do, or the developer failed to do, implement such proper checks, and as a result, access was exposed and people actually was able to access something which they are not supposed to do it. That's it. It's as simple as that, right? Now, definition of access changes. So this was a very popular hack, Temple DAO. It's a DAO which actually was created to actually minimize give you a high returns. To be honest, basically, it's a way of get more returns from the investment you are doing. The funny thing is, in 2022, which is last year, it got hacked, and over 2 million worth of Ether lost due to this thing. So this was massive, right? So like 2 million is not a small money, right? This is correct. Now, this was the few transaction history. So you can see there was in Uniswap, it happened like 2.3 kind of million dollar worth of Ether got transacted. And these are all already available. If you go to EtherScan or something, you can find all this data. We have also given the references. Okay. So let's talk about how it happened. So this is the source code of the smart contract of Temple DAO. So there was this migrate stake method was there in this code, right? And what this method does, it actually can migrate and withdraw the money from one account to another account. Very simple, straightforward, right? You want to migrate. There's some money is there in one address and you want to just migrate to another address. As simple as that, right? Now, what is the problem? The problem is this method, it was public, as simple as that. It's like accessible to everybody and anybody. So anybody can actually call this method, and this was the code which is a hacker has executed, or a vulnerable exploitation code, where what I can do is I can create a method and call this with my smart contract or whatever, wherever I want to migrate, and then it will simply pass that money or the fund to that, right? So it's as simple as that. So it doesn't need, it's a no-brainer. As a developer, I can see there's a migrate method. I can migrate, it has access, and I see this is live, there's money. I will just call it to kind of transfer all the fund to my address. Now this is, see how stupid it is. It's very simple, and it is not an old thing, right? I'm talking about 2022, last year, right? So it means these are the silly mistakes developers are doing even today, right? So it's how serious is this? Now, how this could have been prevented? Majorly, there are two kind of approach you can follow. One is obviously this function should not be accessible by anybody. I mean, it's a very admin kind of method, right? So that's why this method can only be used by the owner. That's number one. Second is, even if let's say owner is kind of using, you can put a second layer of defense, which is like you can only allow whitelisted address, which means if at all I want to migrate or transfer that, just before that, it has to be whitelisted, which is when I only predefine that, these are the places only I can actually transfer. So with this in mind, if we can modify the code, this could be a modified code, which can actually help you to probably could have helped us to prevent this, this kind of issues. What is that? First is the function, which was external only. Now we actually add this, modify for only owner. So as a result, it is only the owners will be able to call, right? So it's not anybody able to call this. And second is kind of the address I'll be passing first, and there is a whitelisting approach. So if it is whitelisted, which is this, this is something has to be defined in the past. So if it is there and this method is called, and it's been added to the list whitelist, so then this validation should pass. And if this validation is passing, is whitelisted, then only I should be allowed to call the micro method, the withdraw method. So see, this is a simple fix. It's all about mindset. It's about how you design a code, right? So what we say generally to developers, you should have a fail first kind of mindset, which means you should start with a no. Always not accept all, reject all method. So if I have to transfer something, let's say I will validate everything, all possible scenarios first. I will first think about, okay, what are the ways it can go wrong? Let's write down all those validations. And then finally, I'll write the actual logic of, okay, what is the function should do? Or what is the happy path which should do, right? So this is how it should be. So this is how you can actually write. So that's what I'm saying, all possible validations. So even before writing the method, which is take a pen and paper, understand the situation. What is this function supposed to do? And what are the ways it can go wrong, right? Who should be allowed to call this method? Where it should go, the data, what kind of parameters accepting, and what validations should be there for the parameters. Think about all possible scenarios. Write down. It's a very conventional way, old school way. Write down in a pen and paper. And this is also goes to a different area of security called threat modeling. You actually try to proactively think about what are the potential threats could arise or could happen, right? And then you model that, and then you write code for it. So this is how you should write all the code, and then finally you do the happy part. Happy part means ideally what it's supposed to be. So don't have any trust on anything which is coming. So always do all validations. Like it's called zero trust approach. So you actually go and you don't trust anything. Do all validations. Do all possible verification, and then you do that. Right. These are some of the references of this hack, the walkthrough, and everything. What I'll do is I'll also kind of share these links in the description of the video, right? Now let's move to another interesting vulnerability called reentrancy. Now reentrancy has been one of the oldest vulnerabilities. It's been there for ages in the industry. However, still valid. Even today also there are a lot of smart contracts has this vulnerability. Now, what is this reentrancy vulnerability? Reentrancy vulnerability is a way of, it's like a recursion. Like let's say I call a method called withdraw. And before this method finishes its execution, in between, there is a call to another method, probably a fallback method to another smart contract. And then it could be the same contract but another contract. And then inside this method, I call back again withdraw. Now see this, what happens? So this method is getting called, this method is not executing, and then before it finishes, let's say in between, it has a call to fallback method. Now inside the fallback, I call withdraw again. Again, we go to withdraw again calls fallback, and it goes like this as an infinite loop until some risk condition arises, like maybe funds got over and blah, 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 like that, right? You don't have enough, kind of, let's say, money fund to even to pay the gas or something like that. So but it is an infinite low cost. Now what essentially that means? That means you can drain out. You can drain out a contract because of this method, because there is no validation, and this is an infinite loop which keeps, let's say, withdrawing money from one account to another account, right? So that's what I'm saying. This is a visual representation of the same thing, which is, let's say, contract A calls method. So contract A has a, let's say, withdraw, it calls a withdraw method, and then there's a fallback, and from there it calls again contract A, like that. It keeps rotating and then from each other. Let's see an example, then it will be able to understand. So this is a very basic example. Let's say you have an unsafe bank as a smart contract, right? And which is a withdraw method. And what you can do is, I can actually call the withdraw method, which actually calls, transferring ether. And as I say, in this method, there is a way I can call fallback. In the fallback method, I call again a withdraw. So again, it will call withdraw. Again, it will transfer the money. And then again, it will go to fallback. Again, I'll call withdraw. Like that, I can actually withdraw more money from, let's say, this bank before, than what I, supposed to withdraw, right? So this is how it works. And as I said, it is a very interesting hand because this leads to a historical moment in the history of Web3 and Ethereum, to be precise. So in 2016, there was a DAO called DAO, and that got hacked because of this vulnerability. And it was a 12 billion worth of Ether. So 12 million Ether worth of around 150 million at the time was stolen using this vulnerability, right? And that's like massive. And these are the various transactions. History is there, which is still there in the this kind you can see. And the historical moment is, if some of you probably know, this is caused a huge thing of branching from Ethereum to Ethereum Classic. So what essentially happens is, it was that time, it was the main Ethereum, like one Ethereum, and then this hack happened, which was massive. And then there was a two school of people. One set of people said, by principle of blockchain, we should not do anything about it. There was a like because it is the principle that what happened. I'm not supposed to there's no modification I can do. But then the other side of people said that this is something massive. We should revert the transactions and probably fix this issue and move on. So eventually what happens, the first set of people who are also in principle right, they stick to the Ethereum Classic, the original Ethereum blockchain, and then it's called Ethereum Classic. However, this transaction has been reverted, and that caused this hard fork, and that hard fork created this new branch, and then that is called the Ethereum, right? So it was actually a very interesting moment in the history of Web3. Now let's talk about this code, how it. So this was a code, let's say a split out. So essentially the idea is, let's say this function is supposed to split and transfer some amount to another account, right? And there was this withdraw reward. So if you do that, and there is a reward function where you can withdraw the reward. I'm not getting into too details with the interest of time. We generally cover this in our full workshop. But then you have this code, the block, and I'll share all the references which you can read also. So there was this withdraw reward 4. This is the function was there, and you can see this function. There is a funds to be moved has been calculated, and then eventually there was this method is called to withdraw the money. Right now, inside this withdraw reward 4 method, there was, if this all validation passes, there was a payout method, right? And this is why the problem comes. This payout method takes the account, and it will actually does a payout. It's a multi-stage attack because this happens in a stage by stage. So there's a payout which does a payout. So it's a straightforward. Like I think as a developer, you can see it's simple. There is a withdraw reward, and from withdraw reward, I'm doing some validation, and from validation, then after that, I'm doing some payout. However, the problem is inside the payout, there was call method, right? So with this, I can call and I can transfer them. And this is where the problem comes, because if I see the vulnerable code, let me see if I have it. So, okay, I don't have it here. So with this, if you go back to the first method, it's getting withdrawal, and then from there, I can use this callback to call again this method withdraw, and that's how it can loop. And the reason it happened because you're updating the balance after this. So had it been this balance has been changed before, one of the validation would fail saying that you don't have insufficient balance. But in this case, what is happening is because this call is happening, and then there is a callback, and with that I can create the recursion. And that is happening before the balance has been updated. So by the time I'm rotating and creating this, my balance is still original balance of this account, right? So as a result, Money is not actually, the validations will pass. However, I keep draining out. So essentially the objective is if there is operation of withdraw, send or something like that, we always say you should update the balance, and after that we should do that. Because if you don't do, there is a high possibility of this kind of attack might happen, right? So again, we have enough references which we have for this. These are the transactions, and these are the various kind of sorry, these are not the transactions. These are all the yeah, kind of references, and then we have also consolidated a very good reference where it can explain you much better, which you can read it in details. Now, what we can do, right? Let's take some practices to make a better code, right? So first thing, as I said, regarding these two vulnerabilities, access control is a kind of you don't allow all access. You always actually block the access whenever required. Only owner, whitelisting, these are the something we do. For re-entrancy, as I said, there are two primary things we do. Like if the moment you have a withdraw function or transfer fund or something like that, you should always update the balance, and then you should call this transfer or something. And then from there, if you're calling another method or transfer for, like, some kind of multi-stage, like, one function calls another function, you should always do a validation there. Do I have enough, funds there, transfer or not? That kind of things. You can also add like probably a flag kind of mechanism where you can say that, if this transfer is in progress, I will not allow another transfer to happen, another call to transfer to happen. There are the various kind of law we can implement. But apart from that, generically, we want to call about few good practices. One is you should follow good documentation. I know a lot of people probably are following, but what I want to highlight that maybe you're just following because others have told you or probably have seen a sample code, but we want to tell you, little more deep, what exactly this and how it works. Right? Documentation is always good. It actually helps us to make it more readable. As an auditor, we get much more, better insight about the code. If there's a good documentation there. For example, this code, there is no document, so it might, although the names were proper, something, but it will take more time for us to understand, what exactly it is doing and everything, etc., etc. Sometimes developers, as a developer, you might think that I will not write document because if I don't write, then even hackers, it will be difficult for hackers to understand. But see, this is a false sense of security. So there are two ways to do. If I'm a hacker, because the code is public, I am anyway will read, I can run and I can try out and debug and understand the code. The problem I'm trying to highlight here is if you don't put documentation, it is not bringing security. It is actually just make the time understanding process a little longer. However, it is doable. But from an auditor's point of view, when I'm coming as an auditor to help you, your job is to see how you can get more results from me with less time, right? It's not that you want me to spend days time to understand the code, right? If I can understand the code in hours and minutes, it's faster for me to do the analysis and give you the report. So that's why documentation is very important. Don't think if I don't put documentation, code will be secure. It will be like a puzzle, difficult to understand. It is just a false sense of security, right? So this is a good documented code where you have this def, params, and all these things up there. Now, what are these things? Def, params, and etc. etc. These are called NatSpec. Now, NatSpec is a specification format for Ethereum, and then it used for writing comments, smart contracts, and everything. And it will help you to do human related, right? So this is called NatSpec. And with this, you can actually later generate good documentation. I'll show you that in a minute how it happens. So why it's useful? Like, as I said, if you put this kind of specifications, your user experience goes better, that your user interface UI you're building that can read this, parse this, and create like a good documentation. You can create like some documentation tool which can automatically generate documentation for your code base, and it will help you to collaborate better with your fellow developers, your colleagues, right? So how it works, as I said, you can use with / single line command, or let's say multi-line command, you can do /*, **. So you probably are familiar with this. These are various popular tags. notice, param, and etc. So what does this do? Title is the title of a contract. Notice is actually what the function does. You should put it in the description of notice. The displays is giving transactions. And dev, and notice the difference is dev provides extra details, but that's only for developers. It will not be displayed during the transaction. It will only not show to your end users. Param is to define parameters. What is the parameter? What does it do? What is the purpose? Etc. etc. And return describes what is the return of the function. Right now, the documentation, as I said, right? The good part is using the solidity compiler. If you're using solidity compiler, you can use this kind of flags like user doc or -dev doc. With this, what it can do is it can actually compile this this kind of contract which is there written with this NAT spec into a JSON readable kind of documentation, so that this can be used later by some other tool to create a better kind of document. So it actually creates a good JSON, and that JSON can be passed via documentation tool to write documentation on its own. So that way you can also reduce the time of creating a good documentation, kind of for your code. You can use it as a reference, a library. Moving on, SWC registry is called Smart Contract Weakness Classification. It is not maintained anymore, but it still have enough data which is good for you to understand what are the different vulnerabilities there in smart contract. It's a good reference, like a Bible dictionary, where you can actually read and learn more about various vulnerabilities there in smart contract weakness, smart contracts, etc. So that will help you to, more you learn about different vulnerabilities, it will help you to become a better developer, right? Private key is very important, right? Yeah, your key, as I say, right? If you don't have the key, then you lose everything. So never share your keys. Don't hard code it anywhere. Don't copy paste it somewhere. Use non-custodial wallets, smart contract wallets. There's a key management system is there. So in AWS, kind of, I think Google also has it. So you can use some kind of those kind of key management solutions, stuff like that. So these are some good practices you can do. Now let's move on to the tooling. There are some tools available which you can use to do smart contract audit in an automated manner. These are a lot of open source tools, paid tools. Slither is one of the most popular tool. Again, as an auditor, when I work, obviously, first thing I do is simply just go run it through Slither. Let's see what kind of output I get, and then start from there. There's Mitril, Ikinda, Mantico, SmartBugs, Mythex, like that is there. So few of them pay, few of them open source. There's enough documentation available. With interest of time here, I cannot show you, but obviously, you can read it. There's a lot of good videos are there. In fact, if you go to our YouTube channel, I think there's some Slither videos are there as well. How to run Slither and everything. So these are all very simple tool. You can run it. There's some Docker container available for SmartBugs. You can use that actually, to host a Docker and just scan your code. However, the problem with this is this kind of tools is they create a lot of false positives. So you have to be very cautious to parse the results and understand which one is the right vulnerability or which one is a false positive. This is an interesting plugin which is there for static analysis. So you can install this plugin on your Remix, and then if you install this Remix, this will give you some static analysis and give you some kind of whatever findings issues are there, you can find it. So you can actually look into the static analysis tool, and then this plugin you can install, and that can give you, like, in your editor's ID itself, feedback about your code is good or not. Cool. I just want to highlight the career options aspect quickly, because security is massive. There's a lot of opportunities there, and we are always struggling to find good cybersecurity experts, especially in blockchain and Web3 space. And people are actually looking, and you don't have to work. You don't have to switch your job. You can be working wherever you're working. You can do a lot of bug bounties and earn a lot. So you can go to Immunify, hack and prove a different platform, find bugs in others companies, and then you can earn through finding bug and reporting back to them. This is how massive it is, right? And you can see the payouts are pretty big. These are like some historical payout. It's some, these users have got 10 million from Wormhole, 6 million from Aurora, because they have found a bug, reported back to them through bug bounty, and the company have given them that kind of reward, right? So this is massive. So because we are, as I say, security is very nascent. We have very less people now in this space, and we are always looking for good security experts in this space. And you can get also a job in all these companies, the companies which are actually looking for audit firms and who are hiring. Always look out for good people. There's some portals are there, Web3 career portals. Probably you guys are familiar, where you can find this kind of jobs. And as I said, you can reach out to us, so we can are happy to guide you and mentor you on this. And as I said, we have a very extensive course where we actually teach this like in a period of 2 days to 4 days time, and to make you like a master, from beginner to master in Web3. So you can join, subscribe to our community, or as I said, you can book a call or reach out to us for me. So with this, I'll stop. Thank you so much, and I wish you all the best. And I hope to see more security experts from you guys. Please feel free to reach out to us if you want to learn more about security. Thank you so much.
All right, another great workshop there. Thank you so much, Tamaghna. That wraps up the final day of workshops for the ETH Riyadh Meta Web3 Builder Competition. Thank you everyone that has joined us. And please make sure to follow 0x ETH Riyadh on Twitter. Check out the website to keep up to date with the conference. Wishing you all good luck in the competition, and we hope you enjoyed this workshop series. Bye.